So, and that implies that the number of particles we have in one mole will, if all of them is weighed on the chemical balance, it will give us what the molar mass. So, mass of one mole of the substance is what the molar mass of the substance. So, if you have 1 mole of sodium now, 1 mole of sodium contains 6.02 times 6.3 sodium atoms. So if you weigh this on a weighing balance, because there are sodium atoms, it will weigh the relative atomic mass of sodium in grams. So sodium has relative atomic mass of 23 as a constant value. Okay. So the mass of 1 mole of sodium now, in other words, molar mass of sodium atom will now be its relative atomic mass in gram. Okay. So if you have another substance, oxygen molecule, 1 mole of oxygen molecule. Oxygen molecule, the molecule is composition of atoms. So in oxygen molecule, you have 2 atoms of oxygen, and an atom of oxygen has relative atomic mass of 16. So, and you have 2 oxygen. So you just sum up it's like you multiply the atomic mass of 16 by 2 to get the molecular mass now. Okay. So the molecular mass of oxygen in grams will be the molar mass of what? 1 mole of oxygen molecule. The same thing applies to 1 mole of sodium chloride. Sodium chloride. What is the molar mass of sodium chloride? It's simply what? The mass of 1 mole of sodium chloride. So which will be equals to the sum of the atomic masses of sodium chloride, the relative molecular mass expressed in gram. Okay. So we move on. Take note of one thing here. So 1 mole of sodium atom has a mass of 23 grams. So that means there's equivalence of 1 mole of sodium atom equals what? It's relative atomic mass in grams. That's the mass of the 1 mole. Likewise for oxygen, likewise for sodium chloride. So we move on to now. We are given this. Calculate the molar mass of nitrogen gas, ozone. In this case, nitrogen gas of ozone, you need to write the chemical formula of nitrogen gas. Likewise, you need to write the chemical formula of what? Ozone. And from there, you're able to calculate its molar mass. But in this case of K2-07, this is the formula. So you have been given the atomic masses. To get the molar mass, it's very easy. And the molar mass you have to get here is what? The mass of 1 mole of all this nitrogen gas, ozone, and the potassium heptadichromate. So this is the solution to the example. Nitrogen gas is a non-metallic element, so it exists as a diatomic molecule N2. So a single nitrogen cannot exist. Although there are some elements that exist as a monoatomic element, okay, like metal, sodium, magnesium, they exist as a monoatomic element. There are some elements that exist as well, diatomic. Okay. So one of them is nitrogen gas, even oxygen gas. Okay. So the formula of oxygen gas O2, formula of nitrogen gas N2. So now that you have the formula of the nitrogen gas with the N2, so how do you get the molar mass? The molar mass is simply what? The mass of 1 mole of nitrogen gas. And how do we get the mass of 1 mole? That is what? The atomic mass of nitrogen, a single nitrogen is 40. And you have 2 nitrogen atoms there. So that will be 4 times 2. Okay, that's the relative molecular mass of nitrogen is 28, expressed in grams. Okay, per mole of the substance. That means the relative atomic mass of, the molar mass of nitrogen gas is what? Compared to the 28 grams per mole. Then the second one, ozone. What do we have in ozone? The formula of ozone is what? Trioxygen, O3. Okay. So the atomic mass of a single oxygen is 16. So how do we get the molar mass of ozone? That is what? 16 times 3. If you give you the what? The mass. The molar mass in gram. That's what? 8 grams per mole. That is that. So I want to believe you can calculate for K2-07. let me go back to is I want you to calculate the molar mass of K2Cl2O7 and let me see your response. The atomic mass of each of them has been given. Potassium is 39, chromium is 16. So using the atomic masses, determine the molar mass of K2Cl2O7. Bearing in mind that potassium in that chemical formula, there are two atoms of potassium. So this can be interpreted as this K2Cl2O7, the compound, is made up of what? 2 atoms of potassium, 2 atoms of chromium, 7 atoms of oxygen. So, and the value you are giving here is for one atom. So you know how to go about that. It's mathematical. So I want to see your response. What is the answer to molar mass of K2Cl2O7? Quickly. Let's do that. I'm expecting your response. Yes? Anybody? Yes? Anybody? Has anybody gotten the answer? Yes? No response? Or you are still solving? Sonny, you are not contributing to what we are doing because I can see that you're just looking at me. Calculate the molar mass of K2Cl2O7. Given the atomic masses as follows: potassium is 39, chromium is 62, oxygen is 16. So what do you have? Don't waste my time. Please do that on time. Okay. You have to be fast. I'm expecting your response. Yes. What did you get? Well, because you are time bound, so you just have to move on. But I don't know what is difficult in this calculation again. Simple mathematics. 2 times what? 39 plus 2 times potassium is 39. So you have 2 atoms of that. 2 times 39 plus chromium is 52. That's 2 times 52 plus oxygen is 16. 7 times 16. Everything added together. So we give you the molar mass of K2Cl2O7. Has anybody gotten it? If you have gotten it, raise up your hand. If you have gotten the answer, raise up your hand. Signify. Very good. What did you get? You're chatting. You can't see the chat.
294.
Is what?
294.
Correct. Any other person? Any other person? You can speak up. Yes? Correct. Yes. That means from Lapo Lamide 294, Aziz 294, Latif 294, correct. You are right. So let's move on. Now another term you need to be familiar with as far as stoichiometry is concerned is what we call molar volume of gases, molar gas volume. Molar gas volume. Substances that are gaseous. Substances that are gaseous. 1 mole of a gaseous substance occupying a volume of occupying a particular volume at STP, standard temperature and pressure. Okay. gives the molar volume of gas of the substance. So the volume of 1 mole of gas measured at STP is termed with molar gas volume. So 1 mole of any gas, the principle here is that 1 mole of any gas, be it nitrogen, be it oxygen, be it ethane gas, whatever gas it is, will occupy a volume of 20.4 liter or 20.4 dm3. Take note of this. For example, 1 mole of oxygen has 20.4 liter at STP. 1 mole of helium, different gases, okay? All gases, 1 mole of any gas will occupy a volume of what? 20.4 liter. And that we call the molar gas volume. Take note of the one point you need to take cognizance of here is what? The fact that 1 mole of any gas will occupy a volume of 20.4 at STP. Take note of that. Let's move on. Now, as you can see on the screen, I told you earlier on that I'm going to be doing a great deal of calculation in this very topic, and all the calculations are based on one concept. So these are the formulas or formulae relating more to other parameters or other quantities. Okay, as you can see, the first formula is N is equal to mass over molar mass. Okay, so they have written what each of the letters stand for at the right hand side, as you can see. So the second formula is number of mole is equal to N over L. What does N represent? Number of particles over Avogadro's number. The third one is what? Number of mole. You have to calculate number of mole, and you are given parameters like concentration volume. Okay, the formula to use is formula 3. And as for formula 4, that is the formula is the M is equal to over Vm. V is the volume occupied by the gas at STP, while the molar volume is what? 22.4 is a constant value. Then the third formula has to do with what? Calculate number of moles based on what? Concentration and volume. So I think I have a better chart that illustrates the relationship mole has with different parameters. So if you look at the mole at the center here, so that's the relationship with mass. So if you are given the amount of the substance in mole, you have to convert to mass.
God.
Mass mole relationship. You use this formula.
My leg.
Hamid. You're disturbing the class.
Okay. As you can see, can we all see the relationship of mole with different parameters? Mole mass relationship, the relationship between mole and number of particles. Okay, the relationship between mole and concentration of the substance, the substance in solution, and the fourth one is a molar volume, the relationship between mole and the molar gas volume. So you're going to be looking at each of them one after the other. So we're looking at the first one, mass mole relationship. How do you carry out a chemical calculation based on this principle, mass mole relationship? Okay. So the formula, the mathematical formula is very, very important. If you want to do any calculation, you need to memorize those formulas very well. So as for mass mole relationship, so if you are given the amount of a substance in the amount of a substance in mass is measured in gram. Okay. So you have to convert to mole, or you are given the quantity of a substance in mole, to convert to mass. We are using this formula. You have to use this formula, mass mole relationship formula. Okay. Now the formula is what? Amount in moles of the substance in question. Okay. Is equal to what? The mass of the substance over what? Molar mass. That is the formula. Okay, so an example here, how many moles are in 15.0 gram of carbon atoms? You have to calculate the number of moles in 15.0 gram of carbon atoms. So what do? If you are given any mathematical calculation in chemistry, all you need to do is write out the parameters you are given. So the question says how many moles? That means amount in moles, question mark, you don't know. In 15.0 gram of carbon, 15.0 gram stands for mass of the substance. So, and you are given the atomic mass of carbon. So you are looking for mole, you are giving mass. So you just recall the formula that links the two parameters. You are giving mass, you have to calculate mole. Okay, so which formula are you going to use in that regard? Formula is what? Number of moles is equal to mass over molar mass. Okay, now that is the formula as you can see on the screen. So always itemize the parameters given. Amount of carbon is what you are looking for, question mark. Then the mass of carbon now is given to be 15.0 gram. By virtue of the unit, you can always identify what each parameter stands for. Okay, the unit of mass is gram. So you are to calculate mole, you are given mass. Okay, so you call the formula. The formula still remains mass over molar mass. Okay, so you are looking for mole. The mass is given to be 15, and the molar mass in this case is what? Mass of 1 mole of carbon. And the carbon in question is elemental, an element. What is the molar mass of an element? The molar mass of an element is atomic in grams. So why are they giving me atomic mass of carbon to be 12? The molar mass of carbon to be just substitute the formula into the formula. N is equal to mass over molar mass. The mass is 15 gram, then the molar mass is 12.0 gram. Where's the calculation? Are you following? Now we are given this to solve now. I want to solve this question. The first one says what is the molar mass of a substance if 0.4 mole of the substance has a mass of 25 grams? How do you get about the solution of this? Molar mass, question mark. 0.4 mole stands for what? Amount. N has a mass of 25 grams. So you are giving mass. So which formula connects the three parameters? So I'm waiting for your answer. The UTME question. Then the second question says, what is the amount of gold present in 15.5 grams of pure gold wedding ring? So what is the answer to the two questions quickly? Yes? Before we move on, write down the parameters, then write down the formula that connects the variables, then substitute the values and make. Yes. What is the answer to the first one? At least you can do the first one. Mass. Yes, what's the answer? What is the answer to that question, please? The formula is N is equal to mass over molar mass. Okay? You are giving mole to be 0.4 and mass to be what? 25.0. And you have to get molar mass. So if you substitute into that formula, you're going to have what? What's the answer to that question? Yes? What's the answer to the question? Correct. That's good. From Aziz. Latif, that's a very nice one. Nifemi, good. What about the second one? What's the answer? So you can, Sonny, you are not you are not, contributing. What's the problem? If you have to calculate anything, you have to put your pen to paper and do it for me, not just to be looking at me. So so we have looked at the relationship between mass and mole, the calculation involving mass mole relationship. So this one is based on mole mass Avogadro's number. In this case, the formula is amount is equal to number of particles, which can be atomically coherent over Avogadro's number. This is the formula to use. So be able to do this. Yeah, look at this. How many moles are in 9.03 times 10 to the 20 atoms of sodium? So if you use this formula now, what are you going to get? Can you see the calculation? Okay. So we can as well do for this. Because time is up. I want you to do this for me as a class work. Do it as assignment instead of classwork. This. Okay. Do this as assignment. So you're going to continue from the next class. Any question, please? Any question, please? Any question, please? Yeah. Sonny, any question? Can you solve the questions I gave you?
Yes, sir.
Any question?
No, sir.
Do you understand? Did you understand the lesson?
Yes, sir.
Okay. So copy the questions and get them solved.
Sir, we're not done.
Okay. So all the formulas you need has been given. So in the absence of question, I'll call it a day. You have a question? Habib Salami, do you have a question? Do you have a question? Do you have a question? Okay, what's your question? Yeah, what's your question? Yes? Raise hand. Okay, good. At least one. Yes. What's your question? You can type it. Okay, what's your question, Habib Salami?
I don't have a question. I don't have a question.
You don't have questions. Sonny,
Yes,
there is having question. Who is having question? Okay. 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 We'll call it a day. So we'll continue from there next class.
Good night.
Okay. Have a nice day.
Oh my God. Habib, what are you doing?
What?
Eddie.
Do you know?